Okay, you're welcome to my channel today. Today we are come to talk about C++. That's a programming language used in what computing systems. Why do we need to use C++? Though there are several languages we can use them, but why is C++ chosen to be the most easiest one? It is used in every computing systems, efficient, close to the machine programming. It is a language that can be understood easily by the computer. It has object-oriented programming, and it is a compiled language, which is also which makes it a portable program for various platforms. As object-oriented programming in C++. So as said earlier on, the C++ is mostly associated with this object-oriented programming. Yes. So let's skip here and then look or dive in more into the object-oriented programming. So with the object-oriented programming, we are going to learn how to combine data and operations on the data into a single unit called an object. So the C++ was designed to implement OOD, and then the OOD is used with structured design. The OOD is also the object oriented design. Yes, get me right. So the object oriented programming deals with data abstraction, that is the creation of classes to describe objects, data encapsulation for controlled access to object data, inheritance by creating derived classes, including multiple derived classes as well. And then we have the polymorphism, into bracket the Greek for multiform, that is the implementation of instructions, multiple instructions that can have varying effect during program execution. Yes, so it is the polymorphism, and then it can have a varying effect during program execution. So this is the basic structure of the C++ program. So this is the basic structure. Here is it. Here. Yes. So these are the basic. The highlighted text are the basic structures, and it is here. This aspect is here that we type the code to be executed. So let's look at processing in a C++ program. To execute a program written in a high-level language such as C++, use an editor to create a source program in C++. Yes. Use the compiler to check that the program obeys the rules. Translate into machine language. That's the object program. So in order for the code to be able to run, you need to make sure that the code you've inputted obeys the C++ rules or the program rules. Let's dive more into the processing in the C++ program. So we have the linker and the loader. So the linker combines object program with other programs provided by the SDK to create executable code, and then the loader loads executable program into main memory, and then the last step is to execute the program. So this is the structure of how code is being processed and executed. Yes. So let's look at compiling and linking the C++ program. So run code through compiler if compiler generates errors. 1. Look at the code and remove errors. 2. Run code again through compiler. If there are no syntax errors, compiler generates equivalent machine code. Yes, so if there are no errors within the code you've typed, the compiler generates a machine code that the machine will be able to understand easily. And then the linker links machine code with system resources. So let's look at the loader and the executing in the C++. So once compiled and linked, loader can place program into main memory for execution. So once you've inputted your code and texted that maybe there is no syntax errors, the loader can place program into main memory for the execution. The final step is to execute the program. So compiler guarantees that the program follows the rules of the language. So the compiler makes sure that the program follows or obeys the rules of the language. That's, to be specific, the C++ language. Also, the note, the compiler does not guarantee that the program will run correctly. No, it does not mean that since the compiler makes sure that the code or the program follows the rules of the language, it will make sure that it runs correctly. No, you have to check if whether the program or the code follows the program rules. Let's look at the process in terms of the C++ program. So process is a program loaded into memory along with all the resources needed by the program. Process is a program loaded into memory along with all the resources needed by the program. Each running instance of a program is a process. Yes, so there are steps it takes for a program to be executed, and each process that it takes, or each step, is called a process. So the steps in which it takes for a program to be executed is called the process. Yes, and then the group of all the steps is known as the process. Yes, and each is also called the process. Each process runs independently, so the steps, they work independently. They don't depend on the other before another works. No. So let's look at threads. A thread is a unit of execution within a process. Multiple threads can be initiated from a single process. There are single threaded processes and multi-threaded processes. So this is an example of what threads in a processes. So threads and processes in programming. The program starts out as text file of the programming code. The program is compiled or interpreted into binary form, and then the binary form is the basic language of the computer. That's mathematically the base 2. The program is loaded into memory. So lastly, let's look at some continued aspects of the thread and processes in programming. So the program becomes one or more running processes. Processes are typically independent of one another. They do not depend on the others before they work. No, each process or each step work independently of one another. threads exist as the subset of what? A process. It means that the threads are derived, or they are formed from the what? Process. Threads can communicate with each other more easily than processes can. It means although the processes also communicate with each other, the threads do communicate with each other more easily than the processes can do. Yes. So with this, we bring an end to this first lesson. Subscribe and then watch out for the second lesson. Thank you.